Welcome to the Landbridge podcast. I'm Lucinda Horrocks. Marine ecologist Associate Professor Neville Barrett has spent many research hours on Bass Strait on a survey vessel mapping the seabed and investigating the marine life of Beagle Marine Park. Beagle Marine Park is a Commonwealth Marine Protected Area in Bass Strait, southeast of Wilson's Promontory. The marine park takes in the sea around three groups of small islands, the Hogan, Curtis and Kent Island groups. During the last ice age, at peak coldness around 30,000 to 20,000 years ago, these islands were hills of a vast plain connecting mainland Australia to Lutruwita, Tasmania. When the ice age ended and seawater levels began to rise, the Bass Plain was gradually submerged. The area around Beagle Marine Park became one of the few remaining places of high ground, forming the last walkable land connection to Lutruwita, Tasmania, before sinking beneath the waves somewhere between 14,000 and 8,000 years ago. In this episode, Neville shares what he has learnt about the unique marine biodiversity which exists today in the seas which formed in the strait in the 10,000 or so years since the land bridge was last exposed above the waves. He also talks about how technology is helping us map the seafloor so we can visualise what that former and now drowned Bassian landscape may have been like. This conversation took place in Nupaluna, Hobart in 2023. If you're interested, you can watch parts of this interview in the Landbridge documentary film, which is freely available to view from the Landbridge website at thelandbridge.au. I've added the hyperlink to that documentary in the program notes. Okay, here is Neville. Well, Neville, thanks for joining us.
A pleasure.
We're here to talk about the ancient land bridge that once joined Victoria and Tasmania. Can you tell us what is a land bridge?
Right, well, I guess it's not exactly a very exciting looking bridge. It's simply really going back during the last glacial period, it was just really pretty much a vast sandy plain that extended between Victoria and Tasmania. At times it was, just one strip going up through the Furneaux group out toward Wilson's Promontory, and, that really it might have only been tens of kilometres wide at one stage towards the end of the glacial period. But at the glacial maxima, 20,000 odd years ago, that land bridge also extended across western Bass Strait and eastern Bass Strait, completely closing off Bass Strait between Tasmania and Victoria, so that there was just a large lake in between what are now two distinct states. And of course, as the sea level's risen, it's opened up the western entrance to Bass Strait, and just to the point we just had one narrow strip of land coming down from Wilson's Promontory area in Victoria down towards Flinders Island. And, obviously very important in isolating the biology from various sides of the country and state, leading to speciation and all sorts of things going on over those periods, but also very importantly for the Indigenous people that used as a corridor to migrate backwards and forwards between these kind of regions.
Mm. You mentioned a couple of science terms, so we might kind of unpack, but what do you mean by the last glacial period and the last glacial maximum, and how long ago would that have been?
Okay, so we've had lots, I guess the Earth's gone through lots of glacial periods where it's cooler than it is now, and that really results in a lot of water being locked up in ice and glaciers around the globe, leading to a decline in sea level. So there was been quite a large one that went really from over 100,000 years ago and pretty much extended going up and down in intensity until about 10,000 years ago. So during its peak, around about 20 to 16,000 years ago, the sea level was actually about up to 120 metres lower than it is now. And that's kind of when both western and eastern approaches to Bass Strait were completely dry land, just with a lake in the middle. If we roll forward, as things warmed up a bit about 10,000 years ago, the sea level rose from that minus 120 up to where it was then, around about minus 60 to 70 metres. And that just enabled that small, narrow corridor to sort of stay open for a few more thousand years till about 8,000 years ago.
That was great, thank you.
Good.
And what happened once the sea rose? What happened to the life and the ecology and the environment? Because suddenly what was land is now underwater.
Well, that's right. It would have been for many, many thousands of years a vast sandy plain in Bass Strait. We don't know too much about how vegetated it was, but I would imagine there's a lot of sand there now, and some cobble kind of ground. But otherwise, it would have been probably would have been a vast sandy plain, just interspersed with a series of lakes throughout the middle. So, at the time, there would have all sorts of things roaming around there. Lots of emus. We know the emu in Tasmania was kind of its own unique species, but it's extremely closely related to that at Wilson's Promontory in Victoria. They're smaller than the standard mainland emu, and they would have been well connected even 10,000 years ago, roaming backwards and forwards across those plains. But at the same time, that land bridge actually, during the glacial period, actually isolated the entire marine systems of eastern and western Australia, because any typical, say, rocky reef species that lived on our coast, it would have to migrate around the bottom end of Tasmania if it wanted to head to the west of Australia and vice versa. And at that stage, the temperature of the sea was much colder than it is now. So it was a big barrier to species migration, and it actually caused a lot of speciation, where different populations couldn't get together anymore, and they actually evolved into different species, which was quite unique. Following that period, of course, that whole area went underwater, and now Bass Strait is this kind of a quite unique, really large water body of fairly shallow water, about 60, 70 metres across all of Bass Strait, inhabited by just a whole range of different species. But again, it's mostly a big sandy plain, so it's not as diverse of a range of habitats that we find in many other reef areas, because it just doesn't have that kind of wave action that exposes bedrock and creates reef and things like that.
So still a grassy plain, but it's underwater.
Very much a grassy underwater plain, without the grass, of course.
Without the grass. Sandy plain is what I meant. It's a sandy plain.
It's now a sandy plain. There are areas of seagrass where Bass Strait's shallower, but most of Bass Strait's 60 metres. So most of Bass Strait is deeper than where light penetrates enough to grow seaweeds and seagrasses and things like that. So it's really the realm of fishes and scallops and things like species like that. But there are some unique features in there, and one of those is the unique drowned dune systems in the Beagle Marine Park, where those dunes have actually calcified, so they've become hardened back in the time when there was a lot of fresh water around, and they form a really rare and isolated rocky reef system throughout the centre of Bass Strait that's home to incredible diversity of sponges and a lot of other life.
And that Beagle Marine Park is sort of right in the centre, or one of the points where that bridge was till the end, isn't it? That in that kind of eastern section of the old Ice Age land bridge.
Yeah, look, absolutely. A big part of the Beagle Marine Park is very much represents the last remnants of the land bridge as it disappeared underwater, all that time ago, 8,000 years ago. So it's quite exciting, really, because it's got a number of angles to it, really. It's kind of representing elements of the land bridge itself. It's also representing some of these, what are now these deep reef systems that back in the day would have been very much shelter for Indigenous folks travelling backwards and forwards across the strait. Because not only back 8,000 years ago or more would it have been a sandy plain, it would have been a very, very cold and windy sandy plain. And so, these kind of shelters, again, these reef systems now, would have been very important shelters for people kind of just living and migrating through that area.
It's amazing to think about that. I know. It was very evocative the way you spoke about it as being sort of the last connection, really.
Yeah, well, that's right. Well, it was, yeah, that's right. And it wouldn't have been particularly wide, towards the end, so 10, 20 kilometres wide, but there's not much as you're going all the way across Bass Strait.
So when you think about the land bridge, what to you is appealing about the story?
Well, I guess there's lots of things. For me, well, there's clearly an underwater component, and that's my interest and passion, the underwater world, and that it does encompass parts of these rocky reef systems in the Beagle Marine Park that are quite unique in a Bass Strait kind of sense. So that's exciting because it's also in an area where there's high currents and lots of food, so it's a very kind of locally productive area. But just the whole rest of it's fascinating. I've spent a lot of time working around the Bass Strait Islands in state marine parks, in Tasmanian Marine Park and the Kent Group, and various other island groups around it, like the Hogan and the Curtis Group. And they're all, again, would have been part of that land bridge. And there are still caves on Erith Island in the Kent Group of islands where the Indigenous folks would have sheltered and lived for probably extensive periods of time. So it's just this great kind of history, really.
Yeah, I love it too. I'm wondering, what do you think a student or the audience might what would excite them about this story?
Well, I think it's just a window into the past, really. About the fact that this whole area has been occupied for tens of thousands of years and used, and there's evidence of that in the caves. But obviously, people would have had to have used that land bridge to come backwards and forwards. There's really no other way of getting to Tasmania. It's just way too isolated to have arrived by any other kind of means. So it's kind of exciting in itself. And there's lots of evidence, at least in the caves and on the islands, of the various things that people were doing and living, and eating back in those times. So it's again a great window in the past. But one of the things we had looked at was to actually see whether there were likely to be any artefacts of Indigenous use around some of those isolated reef systems. Because again, there could be evidence of tools, stone tools, and some of this work, similar work at marine archaeology, has been undertaken in Western Australia, where they have actually found, in slightly shallower water, but certainly evidence of cultural Indigenous use in previous lower sea levels. So, we sort of thought about it, but it's actually very difficult diving and working in 60 metres of water to be able to have a really thorough search, and most things there now are buried in many probably layers of shells and things that have accumulated since. So it's probably a difficult task, but it's one that I'm sure someone one day will have a look at.
So there's definitely the potential that there's evidence, there's cultural artefacts as well as evidence of animals and wildlife. You think still on that seabed?
Look, I'm sure there would be cultural artefacts there. For a start, those particular isolated reefs are very much calcified sand dunes, so they're quite a soft rock type, and anyone living in the area would have brought in rocks from other areas as part of their tools to, cutting and hunting and things like that. So they'll certainly very much stand out as something different from the native rock types of the area, and I'm sure there would have been very extensive use of some of these isolated reef features, for shelter and, literally living in and near to get out of the wind, if nothing else. And, with enough searching, you'll probably almost certainly find something. It's pretty much impossible to go anywhere around the coastline of Tasmania without finding any tools, really, and during, above the sea line. So I wouldn't be at all surprised if there was plenty of evidence out in those kind of areas.
Again, the mind just... It's very, very interesting. I made a mental note. You mentioned another science word. This is going back a couple of questions, which is speciation. Speciation?
Speciation.
Yeah. Could you perhaps unpack what that means?
Okay. So speciation really is the process by which new species form. And, it can be a slow process. But it often is driven by something. And in the case of Eastern and Western Australia, it was very strongly driven by, we believe, by extended glacial periods where the eastern and western populations of a species were cut off, and then over lengthy periods of time, they just naturally evolved different characteristics, slightly different body shapes, different colours, maybe different number of spines on their fins or something like that. And we've got some great examples. You know, there's the eastern blue groper and the western blue groper. There's the eastern blue devilfish and the western blue devilfish. And even some things that still cross over here, like the Australian salmon. We've got not so much, they haven't really evolved to be completely different species, but there's very much an eastern population and a western one. They both mix here, but anyone who's come from the west goes back to the west to reproduce, and anyone that's come from the east goes back up the east coast of Australia to reproduce. So there's all sorts of different stages of isolation, but we see that in a whole range of species. And
that harks to that time when there was actually a land barrier between the different populations in the strait.
That's right, and that, you know, some of those barriers have been there for very lengthy periods of time, and we just, you know, now talking about the more recent glaciation from 100 million odd years ago we're talking about the more recent glaciation from sort of 100,000 years ago now till maybe 10,000 years. But again, going back through many cycles, this has happened quite a number of times in the past as well, and some of them, you know, lengthier periods and some less.
Okay. Let's talk about your research now. So you are an expert in underwater worlds of the Bass Strait. Can you tell us what it is that you do?
No, I guess we just explore more than anything else. That's half the fun of it. Trying to work out what's there, because, you know, for a vast amount of our seas, we've still only just scratched the surface on what's down there. So, you know, for many years we've been diving around the coastline and you know, counting the fishes and the sea stars and the seaweeds and looking at their distribution. But there's a huge area that's well beyond diving depths and been traditionally very, very hard to get to have a look. You know, in the past you might drag a dredge across the bottom, but that's been about it for working out what's down there, or even a net or something like that. But, you know, more recently we've had a whole lot of evolution of technology that really allows us to have a good look now in these deeper environments, and that includes sonar systems. So we've now, you know, part of our work has been involved using multi-beam sonars, which are a complicated sonar system, but it puts out lots of pings of the seabed in a big fan. It just sweeps backwards and forwards as the boat moves along, and we can map the seabed in full three-dimensional structure, which is wonderful. And if we go backwards and forwards enough, we call it mowing the lawn in the boat, up and down all day, we can actually recreate the entire shape and structure of the seabed in places like Bass Strait and see what's down there. And, you know, again, for vast areas of Bass Strait, it is just a big sandy plain, but we're also, for some of the work we've been doing recently, including in the Beagle Marine Park, we've been showing that there are these isolated outcrops of much more special features, these drowned dune systems that have evolved into hard bedrock and forming a reef system. So that's one part of it. And another part has really been using newer technology. So we use robotic submarines, or what we call autonomous underwater vehicles, and they're just programmed by engineers to go backwards and forwards across the seabed, taking many, many thousands of high-resolution images of the seabed, and that actually allows us to physically see what kind of plants and animals are growing on those features that we've previously gone and mapped. So that's the first step. And then we've been going backwards and forwards with other equipment as well. We're particularly using what we call bait underwater videos. So that's a great way of actually seeing what kind of fish are living in the environment in these areas, on the different kinds of habitats, on the sand, on the reef systems, on seagrass beds, and actually looking at their sizes and their population structures without having an impact. And what's important about that is that a lot of the work that our group has been doing in Bass Strait has really been trying to understand what's in some of the new marine parks in the Australian Marine Park Network, including the Beagle Marine Park in eastern Bass Strait, the Bassian Marine Park in western Bass Strait off King Island, and even further over on the east in the Freycinet Marine Park east of Flinders Island. And, you know, it's been really exciting because over the last 15 years we've built up a really good picture of, you know, what lives where and what the range of habitats is. but also, you know, what's actually in those marine parks to help, hopefully help Parks Australia and their management team understand what's in their parks and to manage them going forward into the future.
And what, if you had to paint a picture of this underwater world that was once land and now is submerged, what is it? What's the story of it?
What's the story of it now?
Yeah.
Look, I guess it is. It's predominantly a big sandy plain, almost like a desert, but like all deserts, they're not just sand. There's a lot going on in them. But there are also a bunch of oases in that desert, and in this instance, it's often the outcropping reef systems in the desert. So they're areas where you typically have high current flow. Bass Strait is uniquely quite a high current system. You end up, if you like, in Bass Strait, and this is the defining feature of Bass Strait, it's got quite a high tidal range relative to parts of Tasmania and other parts of Victorian coastline. It's over 3 metres or up to 3 metres. And currents race in from eastern and western Bass Strait and they meet in the middle. So right in the middle, the water goes up and down 3 metres, but it hardly moves. But those eastern and western entrances, it's racing in and up to 4 knots. So it's actually you can't swim against a tidal stream that strong. And that really defines it, because that's going from the surface to the seabed. It's moving things along, but importantly, it's bringing in a huge amount of food, of planktonic food from the ocean into that Bass Strait region. And there's lots of things on the bottom that feed on that. So a lot of Bass Strait is well known to people as a scallop fishery. There are plenty of scallops in there, and the reason for it is that they're filter feeding all of this food that's racing in and out of the currents. So currents are really important for those things, and the bottom's often, defined by the amount and types of filter feeding species you get. So on those big sandy plains, it really is just lots of scallops, and unfortunately also now lots of New Zealand screw shells, which is an invasive species that's taken over the area and thrives in these high current environments. But, you know, a really key part is that the isolated reef systems, that I sort of describe as an oasis in the desert, they're hard parts that other things can actually grow on. So you can get big sponges growing on them, big Gorgonian fans, those great big kind of fan-like structures, types of corals, and they're often very brightly coloured, very intensely coloured, and often quite large features, and they're effectively using the rocks just to hang on to. Otherwise you get washed away in that current if you get big. And they're feeding on all of the food, so they love those high current areas. They're not smashed up by big waves and storms, because Bass Strait, even though its surface waters can be a bit ferocious, it's very calm down there in the deeper waters. The similar depths in the open ocean, there's a lot of water movement, a lot of damage done in big storms, but they're pretty much protected from big storms. So you build up these incredible diverse sponge gardens in particular, and the Beagle Marine Park, one of the reasons it was proclaimed was actually to protect the what were well-known sponge garden areas of Bass Strait, and these reef systems are very much that kind of the pinnacle of that system. So
I'm imagining the sponge gardens, and I know that we're going to have a look at some of the footage of it later, but there's also life that is attracted by those sponges, isn't there? I'm thinking lots of fish and all sorts of things.
Well, yeah, no, look, absolutely. And so the sponge gardens themselves provide habitat to fish, and they concentrate nutrients out of the water column and to help feed a whole big cycle of species. One of the things we really find around those reefs in particular is there's species like butterfly perch forming big clouds around the reefs that are feeding on the plankton that have come through and using the sponge gardens as a refuge, when there's predators around. Other species, we've got some incredible footage of a big aggregation of Port Jackson sharks. And we're not sure that they're attracted to the reef itself to feed on. They tend to be feeding on scallops and things near the reef, but they're using those reefs potentially as a way of getting out of the current. Just like, Indigenous people travelling through the area may have used them to get out of the wind and the weather, 10,000 years ago. And we find, many, many hundreds of Port Jackson sharks just aggregated around some of those reef systems. So again, there's a great project there going forward to work out exactly what they're doing. because we know a few months later they're up in southern New South Wales laying eggs. So they're probably feeding and breeding in that area at the time and just using those reefs as shelter. But yeah, certainly a range of other species are sort of very much attracted to those physical structure, and we see, heaps of different fish species hanging around those reef systems.
Are there any special species that spring to mind?
Oh, for me, that particular area, we've got things like, particularly in the Beagle Marine Park, if that's what we're focusing on now, very much the Port Jackson sharks, to find, accidentally just stumble across a very large aggregation of these species is quite unique. So that's very much a high point or an important point for that park and those unique reef species or reef systems in that park, that they are providing a habitat for, an important part of the life cycle of these Port Jackson sharks. But other things that stand out really are that there's, quite a large number of jackass morlong. People here will call them common perch, I think, that we find in that park, and we see large numbers coming up to our baited videos. And, it's hard to know, but it's an area a species that's been very heavily fished in general, and these parks are actually a refuge for species like this because while they're not fully protected from fishing, they are protected from trawling. It's one of the unique features around the South East Australian Marine Park network, in that you can't trawl in shelf waters in any of those parks. And so many trawl-sensitive species like this jackass morlong are very much protected there. And I guess not surprisingly, we see quite large numbers of them, and it's good to see.
So how does your research intersect with that story of the land bridge? I mean, I guess it was a process of recolonisation by marine life once the waters rose or something. But yeah, you seem to intersect with it in different ways.
Yeah, look, I think there's a couple of aspects to it really. It's, again, the first part really is in better defining it so we can picture it. So, the first thing we did as part of a marine biodiversity hub I was involved with collaborations from a range of agencies, including Geoscience Australia, we went out there and mapped these things. But we mapped it in very fine detail so that you can physically see the three-dimensional structure of the land bridge, of a key part of it at its narrowest point, and these isolated reef features that I believe would have been very important going back 10,000 years ago as shelter. So I think that's the first part. We've actually, provided the ability to visualise what's there. Otherwise, the only, I guess, visual image you've got is just that of a, vast sandy plain. Is about the nearest mental picture you could make of it. But now we've got other components we can add in to tell that story in finer detail. But I think the other part really is just, answering that question is, well, what of it now? And, how what's happening there now? And we can show that those rocky sheltered features from 10,000 years ago are now these amazingly sponge-covered and diverse reef systems that are providing just a real high point in for the biology of that area, and that's a special component as well.
Yeah, I love that. I had a question about. You've already answered about the sea and currents, but I wondered about. Why is the Bass Strait so notoriously difficult a passage, and why could people, why did it block people from being able to cross? And perhaps we could just touch on what it's like today from that sort of perspective of people trying to navigate it.
Yeah. Well, look, Bass Strait is a very difficult body of water to navigate, particularly around the eastern and western entrances where the tides are high. So, while we were talking earlier about the deeper seabed at 60 metres, it's actually quite sheltered down there, and the main thing you've got to contend with is just the currents racing in and out at 4 knots, which in itself isn't that an easy thing to do. On the surface, firstly, you've got currents racing in and out at 10 knots. On the surface, firstly, you've got currents racing in and out at 4 knots, and sometimes more than that. which back in the old days would have been very difficult for a sailing vessel, to actually move against. That's actually the kind of speed often that some of them were sailing at. So you're effectively going nowhere into a tide. But the other thing is that those currents cause large standing waves. They can cause waves to pick up to 5 metres in height just because of the currents. And as soon as you get wind blowing across those shallow areas and across those standing waves, it can really pick up their height to even more than 5 or 6 metres, and also with very, very steep faces. And again, while a bigger modern kind of vessels can cope with some of those conditions, back 100 years ago with sailing vessels, they were extremely difficult conditions to encounter. And so it's a mixture. It's a mixture of the currents. In places, the water does become shallower, and in the shallower waters, the waves tend to stand up even higher. So the current coming in, wind blowing the other way, the waves tend to get very steep faces, and that's extremely difficult for a vessel to navigate in. And of course, many vessels were lost in Bass Strait.
Yeah, that's that. I guess that's that folk history of the Bass Strait just being so, maybe not ferocious is not the word, but unreliable or dangerous. Definitely dangerous.
I guess they're dangerous in another sense too. There's an awful lot of things to run into if you're navigating down the eastern and western parts. Again, if you're sailing, it's hard not to get blown onto King Island, and many vessels did, and there's a lot of wrecks there, and the same around the Flinders Island Furneaux group. There are an awful lot of shipwrecks in that area, just simply because you don't have full control when you're under sail, and a lot of boats just came unstuck. But also because, again, in the absence of a lot of modern navigation, people didn't always know where they were, and there weren't lighthouses in the olden days, I guess, if you like, and people would just bump into them in the night, the islands. So a lot of obstacles as well.
So does your research cover the sort of animals or marine life that is in, I guess, the higher levels of the strait, so that might migrate across, like whales and seals and those sorts of... Well, I guess I think seals go quite deep, don't they?
Well, no, the seals go quite deep, and our particular work doesn't focus on that, but there are a number of other, really great researchers that are. There's been some wonderful work that been done recently on seals in the area, where they've been putting what they call critter cams on them, and they're effectively videoing what they do for the day and recapturing them at the end of the day and downloading the footage, and it's quite amazing, to see some of that, what they've been up to, following even some of the gas pipelines, for example, and picking off lobster and octopus and things that are attracted to those structures. So look, while our group isn't doing that, there are certainly people out there that are filling in those gaps in that broader Bass Strait, and it's always exciting to see some of their latest results when we get them. But going forward, we are starting to, in some of the other Australian marine parks, put down whale listening devices, if you like, passive acoustic receivers to listen to what's there. And certainly going forward, we hope to be doing that in places like the Beagle Marine Park as well, to see what major marine species like whales and dolphins and things are actually using these parks, and in fact when they're using them. Do we have summer winter migrations and things like that? Some things we know for humpbacks, they're very obvious. But for some of the more, I guess, rarer species, we still don't have a clue. And so that kind of tools and technology that people are, using more and more these days will certainly be filling out that picture soon.
It sounds like research is really sort of in an early phase in many ways. You're exploring and discovering in ways that science hadn't been able to before.
Oh, look, yeah, absolutely. Particularly for just in general, really. It's just advances in technology on all levels. Using a multi-beam sonar, really. 15 years ago, they were super rare, and now and very, very hard to operate. And so now, the prices have dropped. They're not quite plug and play, but much easier to use from a technical perspective, and much smaller and compact and reliable. And that's the same with even the other equipment we use, autonomous underwater vehicles, robots. They're just getting easier and more cost effective to deploy into places like this and baited underwater videos. It's just a few small portable cameras in a housing and off you go and you can get good data. Or again, 20 years ago, that very rarely worked well and often didn't work. So technological advances in every aspect, even again in acoustic recording, listening for whales and dolphins. We really couldn't do that 20 years ago. We just didn't have the technology to put something down and listen for 3 months at a time and then go back and get it. It just didn't exist. So yeah, like as technology advances, as you can glue a criticam onto the head of a seal and get that kind of information, we are really starting to build that picture. And importantly so, because there have been a lot of management changes in that last 15 years. We do have these marine parks now that we need to understand what's in them to be able to manage them. There's a real need and driver for that. There probably wasn't that driver before that. There were just sort of fisheries interests, but the managers there didn't really worry too much about habitats. They were really interested in their targeted species. But, we've got I guess at the government level, we've got a group now in Parks Australia that actually has an interest in biodiversity. So we've got there's some ownership really, which is great to drive the research. Research isn't just something you typically randomly do. It's good to be able to do it for an agency that that so you have some relevance, I guess, and uptake, and that's actually happening. But again, in Bass Strait, that need is broadening now because there's But again, in Bass Strait, that need's really broadening now because there's this whole move towards offshore energy and the offshore blue economy, including offshore intensive aquaculture and things. So it's really important that we do understand what's down there, and we understand what's special about it, so that we can make sure that as all of these emerging kind of sectors kind of also occupy that space, that it's all done as as sustainably as possible.
I had a question. You almost answered it, which was about why is it important to value underwater places and create these marine parks? Why do we need to do that as a society?
Well, there's a lot of special things underwater, and we still have only scratched the surface, about what we've got down there. So, there's a chicken or an egg, really. Do you protect things when you find out that they're special, or do you protect representative areas of the coastline in advance of finding out what you've got? In the case of the Australian Marine Park Network, it's pretty well gone in there and drawn lines on maps in the absence of really knowing what's there in the first place. But otherwise you might have waited another 50 years before you had better knowledge to do it. So in their instance, they've protected areas of the seabed, and we're now going back in with colleagues all around Australia to actually understand what's in them. But the importance to protect some of this is that simply we have no idea what our impacts are on lots of these systems at the moment, because we really just haven't looked at anything beyond the individual species level. And yet, at least on the shelf and the upper slope, there's a huge amount of human pressure on these systems at the moment, through fishing, through trawling in particular, and a lot of shelf waters, but there's a lot of targeted fishing that can completely change the way these systems function. And we can lose critical elements without even knowing that we've lost them if we don't have some areas protected, and be able to contrast those with what we're doing in the outside those sort of parks. And so that's a big part. And again, we have all these new emerging pressures. Climate's the biggest driver. We've got climate change and things have warmed up nearly 2 degrees off eastern Tasmania. So in the Freycinet Marine Park and even in the Flinders Marine Park, it's 2 degrees warmer there now, on the surface at least, than it was 30 years ago. That's a big change. We don't even know what it was like 30 years ago because we weren't out there then. We've now started to document it so we can at least understand some of these impacts of climate change and what potentially we are losing. And I think it's even more important in our region here in the very southern end of Australia. Many species here are cold water adapted. Many species here are cold water adapted, and as things warm up, they've got nowhere else to go. There is no shelf area south of Tasmania that they can occupy, and the same for the coastal kind of species. So it's really important for us now to document what we've got, because we may well lose some of those species in the next 50 to 100 years, given current climate predictions.
Yeah, it is important. That was really good. That was a good definition of why it's important to value. Oh, Jerry's watching. So I'm looking at you.
You were talking to me.
Yeah.
It's all good.
Did again with the sound was okay?
Yeah, I really like it.
Yeah.
Yeah.
Oh God, I had a follow-up question and then it's gone out of my head. My follow-up question was, it'll come back if I don't do anything. Yeah,
Sorry too.
you mentioned I guess there was some again defining terms, like you talk about coastal and shelf. What's a shelf? Underwater shelf? That's like a layer, is it, of a level of at which you see marine life?
Yeah, so when I talk about the shelf, it's really the continental shelf. It's the extension of the Australian continent underwater, and typically that's been eroded during past higher and lower level. Typically that's been eroded during past lower sea levels during glacial periods, and so that part of Australia, it might be 50 to 100 metres or so deeper than the surrounding coastlines. Just like the land increases as you go away from the coast in height, it slowly drops away below the water. But you typically come to a point 10, 50, 100 kilometres offshore where you reach the edge of the continent and it drops away. When the continent's pulled apart, since Gondwanan days, you end up with a point where you suddenly go from 100 metres to within a few kilometres, you're actually in a few kilometres deep water. So we call that the shelf break. And beyond the shelf break, it's just pretty much like a 45-degree angle all the way down to 5-7 kilometres in depth. So the shelf is a bit above that, where it's just quite shallow water up until that point where you basically go over a precipice at the edge of the continent.
Wow. And these cold adapted species, like, that's why they don't have much, there's nowhere else to go apart from, they can't find any more cold spots.
They can't find any more cold spots, no. And, sometimes there are places where you do get cold water that upwells from the deep ocean. Right at the edge of the continental shelf, there are some canyons where that happens. But we're starting to find that potentially they're not always upwelling. They're not always providing that colder water safe refuge. Sometimes that upwelling there stops, and so those species, occupying even those areas where they might get some colder water refuge, they're not guaranteed of having it all year round and could be lost during warm periods. So, yeah, once you reach the edge of the continental shelf south of Tasmania, it's only 20 or 30 kilometres south of the coastline. That's it. It's just deep abyss, really, apart from a few seamounts that peak up between here and Macquarie Island and then Antarctica. So nowhere left for many species to go. Because
they can't exist in the abyss. They need to be.
No, that's right. No, most species have pretty well got a depth happiness range. They might be found from 50 metres down to 150 metres, but that's it. So and anything on the continental shelf is typically specialised to be on the continental shelf. It can't live deeper, no.
Yeah, and just finally, Neville, tell us why you love this research. What drives you to do it?
Oh, look, I think I'm really a naturalist, really, just an old style one. I'm not very good at many things, but I like to have a look around. And just curiosity, again, growing up on the coast and wondering why things vary, why species come and go, why some fish are abundant one year and why they're not, led me into working, usually using marine parks as a big scientific experiment to see, well, what happens if you protect an area from fishing? Is it any different than nearby areas that are fished? Are some of the changes we're seeing due to overfishing, or are they just natural, natural variation in year-to-year variation or climate-driven variation? So, working in places like the Australian marine parks, including the Beagle Marine Park, are just a fantastic opportunity. Not only to sort of compare fish with unfished areas, but actually just to go and see what's out there. Because really, until recently, we haven't had a clue what the seabed looks like in Bass Strait, or what key species are down there, and how they vary in space and time, or indeed a range of the other marine parks. It's always exciting to go to another one of the Australian marine parks in our network, because virtually no one's ever been there before, apart from a few commercial fishermen. And we're able to take that information now, and using particularly some of the new online technology, we can share all of this stuff with the public. We can share the maps. We can share the baited underwater video. We can share the pictures of the seabed. All of them are now available on a website, through CMAP Australia, for example, that we link everything to. So it's not only being able to have a look at it yourself and finding it and exploring it, but just being able to share it with everyone, which is just wonderful.
That's where we'll leave our conversation with Neville Barrett. Next episode, I talk to author Adam Courtney about the historic shipwreck and adventure story of the sailing ship the Sydney Cove, which connects to the history of Bass Strait and the land bridge in surprising ways. A range of companion media, a documentary film and other stories are freely available to read, listen to, watch and share on the website thelandbridge.au. The Landbridge digital story was produced by Wind and Sky Productions. Creative producers were me, Lucinda Horrocks, and Jarry Nemo. The credits for this episode are detailed in the podcast program notes. The project was funded by the Australian Government through the Our Marine Parks Grants Program. Until next time, thanks for listening.